Alright, let's build a 1-bit adder and then work our way up to a 32-bit ripple carry adder. So this is the truth table for a 1-bit adder. The input bits, we've got A and B. These are each 1-bit values. We've also got a carry in, and we're producing a sum bit and a carry out bit. And so this is the truth table. Now, we need to figure out, based on these 3 input bits, what the 2 out bits should be. Well, the sum bit's actually not that hard. It's just A exclusive OR B, and then you exclusive OR the result of that with the carry in. And that will get you a 0 when you need a 0 and a 1 when you need a 1. The carry out bit, a little bit more complicated. Basically, for carry out, what we want is at least 2 of them have to be true. Well, A and B, A and CI, B and CI, each of these 3 individual conditions checks to see that at least 2 of them are true. We're checking all the possible pairs, we're ORing everything together. That gets us what we want. Now, what we'd like to do is actually implement this as a circuit. So what we're going to do is use a tool called Logisim to do that. So I'm going to open up Logisim. I'm actually going to open up a totally new circuit, and we're going to start building this. The first thing we need to do is figure out input bits. So up here, these are called, what are these called, pins or something like that? Yeah, these are called pins. We're going to put a pin facing east. We're going to name it A. We're going to put another pin facing east. We're going to name it B. We also need an input bit for carry in by convention. That's at the top facing south. I'll show you why in a bit. So we set these, oh crap, I gotta get this name. This needs to be carry in. These names didn't really save. This is A, and this one should be B. There we go. So we've got A, B, and carry in. Now if we switch to this little finger, we can actually change these bits. So we've got 0s and 1s. Now we're not connected to any circuits, we've just got 3 inputs. Similarly, we have 2 outputs. We have an output for sum. We have an output, and by convention, this will be facing north. For the, that's not what I want, for the carry out. There we go. So, 3 input bits, 2 output bits. Now, there's no signal going to, oh, that didn't save the name. Sum. There we go. Yeah, 3 input bits, 2 output bits. There's no signal going to the output bit, so right now they don't have either high or low voltage. They just have no voltage. Now, we know that we need to use exclusive OR to figure out the sum bit. So we'll close wiring. We'll open up gates. Let's find an exclusive OR gate. There it is. We only need 2 inputs at a time, and we can use the narrow gate. There we go. So there's 1, and I'm going to copy paste this, so there's 2. Now what I want to do is I want to have this first gate do A exclusive OR B. So I'm actually going to just sort of, there's a little, you can almost see it, you can like start running wires out of there. There we go, so that gets us A. Maybe I'll move B up a little bit, and now this might not be enough space. There we go. Actually, I can move that up. There we go. Okay, good. So that's A, B, and then what we want this, and I'm going to move carry in over here, move that down to there, bam. So that's A, B, and then we've got this exclusive OR gate. We've got another XOR gate here. We'll plug this in. So now you see we have output here. Now we can start flipping these bits. If we just have a carry in, but A and B are both 0, we've got a 1. Similar, we've got a 1. Similarly, we've got a 1, and as soon as we've got 2 of them, we got nothing, but then when we add in the third one, we've got 1. So using these 2 exclusive OR gates, we're able to get the sum bit to be correct. Now, we don't have the carry out bit to, working yet, but we will. We're going to work on that next. So for the carry out, we want a couple of AND gates. I'm going to set these down to 2 inputs, and I'll make these narrow as well. Actually, I'll throw in a medium gate, just, you know, you can see how big that is. That's too big. So I want a nice narrow gate, and I need one, and I'm going to copy paste to get a second one and a third one. Maybe I'll move these up a little. And so you remember we want, let's see, let's pull this down for the carry in. So we want carry in and A. We also want carry in and B. We also want, let's see, which one's which here? This looks like A. We'll branch off of there. And then, crap, which one was B? B, right, A and B. So I think that gets us the 3 ands. Now we need an OR gate, and we want an OR gate with 3, and I'm going to make this a wider gate. Let me go ahead and connect that up. So we see we went from no voltage to an error because we don't have any inputs into this. So let's go. There's one input, there's another input, and finally the third input. Perfect. Okay, so now if we 1 and 1 is 0 with a carryout of 1. 1, 1, and 1 is 1 with a carryout of 1. Let's see, 1 with a carry in is 0 with a carry out of 1, and so on. So there we go. That's our basic circuit that we worked out by figuring out the truth table, learning a little bit about gates to do 1-bit addition.